Welcome back, students. So in this period, we'll do few more examples on the relation between zeros of a polynomial, quadratic polynomial, and the coefficients of that quadratic polynomial. So the first question for the day is: 4x square minus 4x plus 1. 4x square minus 4x plus 1. This is a quadratic polynomial. Now you have to find the zeros of this quadratic polynomial, and then you have to verify the relationship between the zeros of the quadratic polynomial and the coefficients. You have to verify those relations. Now, first of all, you know that 4x square can also be written as 2x whole square, because 4 is 2 square, so 2x whole square, plus 1 can be written as simply 1 square, minus 4x can be written as 2 into 2x into 1, because 2 into 2x will be 4x, 4x into 1 is 4. Now, why I have written this in this form? Because you see, now we have a formula of a square plus b square minus 2ab. So we can apply that identity over here. All of you know that a minus b whole square is equal to a square plus b square minus 2ab. Okay, so it is also a square plus b square minus 2ab. Here a is 2x and b is 1. So we can write it as 2x minus 1 whole square. Using that identity, we can write it as 2x minus 1 whole square. Now it is 2x minus 1 into 2x minus 1. It is 2x minus 1 into 2x minus 1. Now, if 2x minus 1 is equal to 0, then x will be equal to 1 upon 2. The other factor is also 2x minus 1, so the zeros are 1 by 2 and 1 by 2. Both the zeros are equal. The zeros are 1 by 2 and 1 by 2. Both the zeros are equal over here. Now, let alpha is equal to 1 by 2, beta is equal to 1 by 2. And if you compare this given polynomial with ax square plus bx plus c, you can see that a is equal to 4, b is equal to minus 4, and c is equal to 1. Clear? If you compare the given polynomial with ax square plus bx plus c, then you will get a is equal to 4, b is equal to minus 4, and c is 1. Now the first one, you know, the first relationship is alpha plus beta is equal to minus b by a. Alpha plus beta is minus b by a. Now you see 1 by 2 plus 1 by 2 is equal to 1 by 2 plus 1 by 2 is equal to minus, that is b is minus 4 and a is 4, like this. Now you know that 1 by 2 plus 1 by 2 is nothing but 1. Here also 4 cancels out. Minus into minus is plus, so 1. So you can see the left hand side and right hand side both are 1. So it is verified. The first relation is verified. Okay, as we are getting the same thing on left hand side and right hand side. Now the second one, alpha into beta is equal to c by a. That is 1 by 2 into 1 by 2 is equal to c is 1, and A is 4. Now you see 1 by 2 into 1 by 2 is nothing but 1 by 4 is equal to 1 by 4. So you can see the second one is also verified. Verified. Okay. Now the next question. The next quadratic equation is quadratic polynomial is 6x square minus 3 minus 7x. 6x square minus 3 minus 7x. First of all, you write it as descending powers of x. 6x square minus 7x minus 3. So once again, we have to factorize this quadratic polynomial using by splitting the middle term. So 6 into 3, 18. Now you have to think of two numbers. When they are multiplied, they give you 18. But as there is a negative sign here, their difference must be 7. So you know it is 9 and 2 because 9 into 2 is 18 and 9 minus 2 is 7. So what we do, we write it as 6x square minus, in place of 7, you write 9 minus 2. In place of 7, we write 9 minus 2. Now, if you open the bracket, minus 9x plus 2x minus 3. Now from the first two terms, 3x can be taken as common. So it will be 2x minus 3. And it is automatically 2x minus 3. Now 2x minus 3 can be taken as common from these two. So in the other bracket, we will have 3x plus 1. Here, can you take 2x minus 3 common? Here only 3x is left and there 1 is there. So we have found that px is equal to 2x minus 3 into 3x plus 1. Now if 2x minus 3 is equal to 0, then x is equal to 3 by 2, that is the first 0. And then if 3x plus 1 is equal to 0, then x is equal to minus 1 by 3, that is the second 0. So the zeros are 3 by 2 and minus 1 by 3. The zeros are 3 by 2 and minus 1 by 3. So now let alpha is equal to 3 by 2 and beta is equal to minus 1 by 3. And if you compare this equation or this polynomial with the quadratic polynomial ax square plus bx plus c, then you can see a is equal to 6, b is equal to minus 7 and c is equal to minus 3. Okay, a is equal to 6, b is equal to minus 7 and c is equal to minus 3. Always remember, the coefficient of x square is a, coefficient of x is b and the constant term is c. If you are directly compare from that polynomial and if you say this is a, this is b, this is c, then it will be wrong. So always remember, the coefficient of x square is a, coefficient of x is b and the constant term is c. Now we are going to verify the first relation, which is alpha plus beta is equal to minus b by a. Now see, 3 by 2 plus minus 1 by 3 is equal to minus b is minus 7, a is 6. First of all, see here, we can take 6 LCM. So 9, 2, minus into minus is plus, so it is 7 upon 6. Now 9 minus 2 is also 7. So 7 by 6 is equal to 7 by 6, so it is verified. So you can see the first equation is verified as we are getting the same number on left hand side and right hand side, 7 by 6. So the first relation is verified. Now the second relation is alpha beta is equal to c upon a, means 3 upon 2 into minus 1 upon 3 is equal to c by a, that is minus 3 upon 6. Now see, if we cancel this 3 and this 3, then on the left hand side we will have minus 1 upon 2, and on the right hand side 3 to the 6. So on the right hand side also we have minus 1 upon 2. So once again you can see the second relation is also verified, because on the left hand side and right hand side we are getting the same number, that is minus 1 upon 2. Okay. The next question. Four x square plus 8x. The polynomial is 4x square plus 8x. Although it has got only two terms, but as the highest power of x is 2, that means it's a quadratic polynomial. So first of all, what we have to do, we will find the roots or the zeros of this quadratic polynomial. For that, we'll factorize it. You can see from these two we can take 4x common, and in the other bracket we will have x plus 2. If you take 4x common, then in the other bracket you will have x plus 2. Now see, you can say that px is equal to 4x x plus 2. Put px is equal to 0. That is 4x into x plus 2 is equal to 0. 4 cannot be equal to 0. So x is equal to 0 and x plus 2 is equal to, either x is 0 or x plus 2 is 0. If x is 0, that means the first 0 is 0, and if x plus 2 is equal to 0, then x is equal to minus 2. The zeros are 0 and minus 2. The zeros are 0 and minus 2. Now let alpha is equal to 0, beta is equal to minus 2. Let alpha is equal to 0 and beta is equal to minus 2. And now if you compare this quadratic polynomial with ax square plus bx plus c, you will have a is equal to 4, b is equal to 8 and c is equal to 0, because the constant term is missing over here. So c is equal to 0. A is equal to 4, b is equal to 8 and C is equal to 0. Now see, the first relation is alpha plus beta is equal to minus b by a. That is 0 plus minus 2 is equal to minus b is 8, a is 4. Now 0 plus minus 2 will be minus 2 only. And if you cancel it, it is also minus 2. So you can see it is verified because the left hand side and right hand side have the same number. So it is verified. And the second one is alpha into beta is equal to C by A. Alpha into beta is C by A. So alpha is 0, beta is minus 2. Here C is 0 and A is 4. Now 0 into anything is 0 and 0 upon anything is 0. So it is also verified, you can see. As we are having the same thing on the left hand side and right hand side. Clear? Next question. Px is equal to x square minus 15. So once again, there is a quadratic polynomial. First of all, we have to factorize it. So what we do, we'll write it as x square minus square root of 15 square. Because you know that square root of 15 square will be 15 only. Now we'll apply the identity a square minus b square is equal to a plus b into a minus b. You know that. So it will become x plus root 15 in one bracket, x minus root 15 in the other bracket. So we have applied the identity a square minus b square is equal to a plus b into a minus b. That gives it x plus root 15 into x minus root 15. Now, if x plus root 15 is equal to 0, then x is equal to minus root 15. That is the first 0. And if x minus root 15 is equal to 0, then x is equal to root 15, that is the second 0. So the zeros are minus root 15 and root 15. So the zeros are minus root 15 and root 15. Now let alpha is equal to minus root 15, beta is equal to root 15. And if you compare this polynomial with the quadratic polynomial ax square plus bx plus c, then you can see a is equal to 1, b is equal to 0, c is equal to minus 15. A is 1, b is not there, x, the term containing x is not there. So b is equal to 0 and c is equal to minus 15. Now you see the first one, alpha plus beta is equal to minus b by a, means minus root 15 plus root 15 is equal to minus 0 upon 1. Now minus root 15 plus root 15 cancels out, only 0 is there and minus 0 is 0. So it is verified. The first one is verified. Okay, the second part, alpha into beta is equal to c by a. Alpha into beta is c by a. Now minus root 15 into root 15 is equal to c is minus 15 upon 1. Now you see root 15 into root 15 will be 15 only, and minus into plus is minus. So minus 15 on the left hand side and minus 15 on the right hand side. So this is also verified. The second relation is also verified. Now the next question. Next question is px is equal to 3x square minus x minus 4. 3x square minus x minus 4. Now what we do? First of all, we will factorize it, and we will factorize it using by splitting the middle term. 3 into 4 is 12. Now two numbers whose product is 12 and whose difference is 1, 4 and 3 only. So you write it as 3x square minus 4x plus 3x minus 4. You can see things are the same. Now from the first two terms you take x common. So it is 3x minus 4. From the next two terms, you just simply write it. It is also 3x minus 4. Now you take 3x minus 4 common. So in the other bracket, you will have x plus 1. So in this way, we have factorized the given quadratic polynomial, and it is 3x minus 4 into x plus 1. Now, if 3x minus 4 is equal to 0, then x is equal to 4 by 3. So this is the first 0. And then if x plus 1 is equal to 0, then x is equal to minus 1. Now, so the zeros are 4 by 3 and minus 1. The zeros are 4 by 3 and minus 1. Let alpha is equal to 4 by 3, beta is equal to minus 1. And now if you compare this equation, this polynomial, quadratic polynomial, with ax square plus bx plus c, then you will get a is equal to 3, b is equal to minus 1, c is equal to minus 4. A is equal to 3, b is equal to minus 1, and c is equal to minus 4. Now the first one, alpha plus beta is equal to minus b by a. Alpha plus beta, that is 4 by 3 plus minus 1, is equal to minus b is minus 1 and a is 3. Now if you take 3 LCM here, 4 minus 3, minus into minus plus, so 1 by 3. 4 minus 3 is also 1, so 1 by 3 is equal to 1 by 3. Okay? So it is verified. The first one is verified. Now the second one, alpha into beta is equal to c by a. Now 4 by 3 into minus 1 is equal to c is minus 4 and a is 3. Now it is minus 4 by 3 is equal to minus 4 by 3. Once again you can see we are having the same thing on both sides. So again it is verified. So you see here also both the relations are verified. The relations between the zeros of a quadratic polynomial and the coefficients of that quadratic polynomial. So I hope all the examples that I explained today is clear to you. Now in the next period, we will do few more sums and we'll conclude this exercise. Okay.